Hello everyone, welcome back. This is the Vintage Sewing Machine Garage YouTube channel, and today I am going to talk about the amazing. These are two examples of what is arguably one of the finest sewing machine motors ever made. And of course these are direct drive motors used in a number of Singer sewing machines. Now the direct drive motor idea originally appeared on a Singer model called the 101, which I have never shown on this channel because I don't know how many of them got sold. I'm sure they're out there. I've seen them, but not locally. And the 101, I believe, was the first Singer to have a motor that did not use a belt. And then a similar design, but an update to that was created for sewing machines like the Singer 15-91, the Singer 201, for example. And those machines had sort of a newer version of that motor, which many people often refer to as the potted motor. That's not a Singer term. That's just what many people today use to refer to that particular machine because it looks, according to some, like a little pot. Well, Singer didn't stop there, because if you've ever seen either my videos or others talking about those potted motors, they are incredible. They're beautifully made, but in terms of servicing, they take quite a lot of time to disassemble, to access. And I suspect that when Singer got ready to create its Slant-O-Matic series, they for the issue of servicing and others, it may have had to do with how to package the motor, because of course the Singer 301, which was the first machine to get this style of direct drive motor, that machine was a very different shape than say the 15 series or the 201s and the 101s. So today I wanted to show you a couple of iterations, and these are not the only ones. They're the ones I currently have access to at the moment. This particular motor is called a PA, like Paul Apple, 2.8. And I don't know if it will show up here when I do this magnification. Might help to remove the dust there. I'm going to try to hold this still and I'll show it to you. It says PA, or Paul Apple 2.8. And of course companies always need to have codes on their, and they may have even had a serial number there, but the codes matter because companies change things over time. For example, this particular one here that I just called out as a 2.8 PA, this is from one of the early Singer 301s, and you can tell that not only because of the code, but you see grease ports, right? This is a lovely port that holds a wick, and when you service it, you replace the wick if you have to, if it's called for, but that's where the grease goes to lubricate the bushings of the motor. This motor does not take oil, it takes grease. And I know that because Singer says so, and Singer used to say so and back in the day. Now, over time, this motor, they would create other versions of it that still looked like this, but then the port went away. And the only way to service the grease would have been to disassemble the motor. And I have a BA, a different kind of motor, Bob Apple. That motor in a somewhat recent video, I showed in Motor Series how to take one of those apart and lubricate it. It sure would have been nice if the Singer had left these grease ports, because they make things just more straightforward and more efficient. But for whatever reason, they did not do that. And so I suspect when I get around to overhauling my Singer 503, it will have a motor that looks sort of like this. It may be brown colored in the plastic, but that's neither here nor there. It's going to look like this, but it won't have the port. By 1958, 7 or 8 years between when this comes out in the 301, and then when the 503, by the time we get to that series, Singer has done away with the port. Well, I have shown before there is, of course, an access bolt here, and this is what the cap or the access to the brushes looks like. And one of the brushes is not in this motor. I've been having to inspect and diagnose this motor to see if it is salvageable for the 301 that I have in my, it's in a queue waiting for me to get to overhaul. But the main focus of the video today is this motor, because this version is called, and it's a little easier to read, it says PA 10-8 or Paul Apple 10-8. So this was one of the last versions of this motor. There may have been others, but this would have been one of the later ones. This is early 1960s. To Singer's credit, they were still, it's still a quality motor. I'm not aware of any quality differences. Of course, there is of course no grease port, right? If you're going to grease this, it's going to have to be done just like other motors that don't have the ports. Now, one thing I've noticed here is at the very edge of the worm gear, this of course is the gear that interacts with the Textolite gear on the hand wheel to drive the machine. And if you look on this side, this is of course on the left, you see the older motor from the 301. Again, very similar. This one's dirtier. This one, this sort of aluminum housing here. And if you look at the worm gear, it's kind of interesting. What I think I'm seeing, and this is just, I haven't measured it, but visually, what do you folks think? I think that the worm gear got slightly narrower. There's nothing wrong with it. This is still a beautifully made gear. I'm not really critiquing it, just observing that this is, okay, so we have an access hole here. We have, so there's a bolt that would allow you to remove this if you had to. And that's because there is a bearing, an actual bearing, not a bushing, down in here. And I've shown this before in videos. The bearing sits at the base of this worm gear. And I've shown techniques before on what you should do to, that bearing would have had grease, and many of the bearings continue surprisingly to run well, but there is a technique that I have where I use a special kind of oil. I say special kind. It's not sewing machine oil, that's too thin, but it's called SAE 30 weight oil that I got in a automotive shop, car parts store. And what I do is I use that sparingly, 1 or 2 drops, and that oil can work its way down. You can even add a little heat. And what the oil does is it sort of, it reinvigorates the old grease. That's the idea behind it. And okay, so what else is different? Look here. You will see that on the end of the worm gear, this on the right again is the later iteration of the this PA style direct drive motor. This is, I'm going to call this my favorite motor, honest to God. It is incredibly reliable. It's much easier to take out of the machine than the old potted motors were. And they rarely cause issues. They can, anything can have a problem, but I have not found them. But look at the ends of the worm gears. This one has what looks like, I don't know if this is if it's a crush washer or some sort of riveting technique. I'm not really sure what that is. It looks like a nut, something you could unscrew. But anyway, that is on here, and this one does not have that. But I don't think this is missing. I believe this was a running change. Another thing you may notice is that when you look here, you're going to see, I can shift the camera, you can then look and see what I'm talking about. All right, so notice the one on the right, there's no hole, but there is a hole here. And yet, you can see they both still have their wonderful brass contacts. Of course, those brass contacts are where the the wire leads get connected. Again, just it's a servicer's dream, and I know that the shape of the motor is different because Singer, the Slant-O-Matic series is a it's just shaped and it's a little bit taller, I think. They needed to change the motor, but I think they also listened to their service personnel. Remember, Singer was, like many companies, was organized in a very vertical way, so they didn't outsource very much, and you could hire Singer's own service employees that they worked for the same company that made the machines, and they had their beautiful service trucks. You can see old photos of them, and you could certainly sign a contract, say, would you like a service agreement so that we can come out and maintain your product for you. That was an option for people. So I just thought I would show this to you because, again, they look very similar, but they made changes. And I don't know if was the grease port that much money that they quit using it? I'm not sure. Because so much of this, I believe, was maybe it was just simply driving people back to the dealer to have them do more of the service. I don't know. But just wanted to share that with all of you because I've never really talked about these motors in particular. But today, the reason this one is here is I'm going to show you how I'm going to open up for the first time. But again, it's sort of familiar. I'm going to open up the brush cap, which these are giant brush caps, which I love, unlike the ones you get later on in the 60s, which are just little, they're not made very well, but they work. They're okay. I'd rather have any brush cap than none, but these are just, it's hard to believe that this much effort and attention was once given to the motor of a sewing machine. So I just loosened the bolt, took this cap off. It's shaped a little bit different, but it's the same basic design, I think. Now, what am I doing? I am looking here. I'm going to show you, this motor is going to make this a little easier to see than some, because if my lovely sunlight coming in here is going to help us, and I'm going to zoom in here and I'm going to show you why this is useful. If you look, I'm going to try to hold it still so you guys don't get seasick on me. Okay, notice this, of course, is the brush holder. Okay, it's made of brass, it's gorgeous, but notice there's a slot or a slit in the side. That is there to help you see the brush, so you can tell without taking the holder out and taking the brush out. I could do that, but I don't need to, because look right there. I don't know if you guys can see this, but even the spring shows up. Maybe get even more zoom here. Yeah, let me try to get that position for you all. Look at that. Do you see? I don't know if you can see the texture, but I can see the texture of the spring here, and then right here it stops, and that's the brush. That's a 1/2 inch. That tells me that this motor, unless this machine got used so much that the brushes had to be replaced, yes, that's possible, but brushes take a long time to wear out. But I always check every machine I have. I check the brushes because I can't assume to know how much wear the brushes are. Maybe they were replaced in the past, or maybe they weren't, or maybe someone used the machine a lot and just they didn't scratch it. So I just always want to know. But these brushes are in incredible shape, and this machine, I am going to basically call out and say, this machine did not get much use. Very few hours on it. Like a new old machine. That's what I sometimes call these. Okay, so why else am I looking at this? Well, we have, of course, a commutator. A nice thick copper commutator. Modern electric motors use some copper, but it will not surprise you to learn that modern electric motors use less copper because they're cheaper and they don't want to spend the money on the copper. Yes, that's true. The commutators I've never measured. I would not be surprised if a modern reproduction electric motor for a sewing machine has a thinner commutator. And again, I'm grateful that I can get generic motors to replace those that are dead. That's fantastic, so I'll take it. Don't get me wrong, but these are just amazing. And if that makes me sound like a nerd, well, so be it. Okay, so what am I going to do now? Well, if you know how I approach my motors, I am not removing the armature from this motor. I could, and in the distant past, I used to do that, and I'd take them out, and I would, cut sandpaper, very fine sandpaper, and I would polish them real shiny. I do not do that anymore, and I don't do it because, as I've mentioned in more recent videos, it creates a situation where, getting myself some of my extra fancy cotton swabs here that I got in a cosmetic department. Now, what I do is I take 99% isopropyl alcohol, and with that alcohol, I wet my my cotton swabs, and then I will clean any of the carbon dust or graphite dust off from the brushes that naturally gets on a commutator over time. I clean that off. I do not sand them. I know some people do. Some people believe that they should. But honestly, electric motors are very forgiving. They need to be cleaned, but they don't need to be ground down. Because yes, it was shiny like a copper penny when it was new, but it didn't take very much use to get that little, you can see the little black stripe here. That's just residue from the brush, and I will clean it off. It's not difficult to do, but I don't want to, even if I can do it in a balanced way, I do not want to sand copper off of the commutator, because when you do that, you shorten its life. When the commutator's copper's gone, that's it. The motor, you're going to have to get a whole new armature or just replace the motor. And the other issue you might have is that when you sand any kind of metal, and particularly copper, because copper is very soft, right? It's like aluminum. It's a soft metal compared to steel or iron. And if you sand it and you get copper dust inside that motor, well, that's not really a good idea, because metal conducts electricity. So this is more of a conservation approach, right? We're not going to tear it all down and grind it down. No, it will be fine. It will give plenty of power, because much of the residue can be removed with this method that I use without losing any of the copper surface. Okay, now when I start this method of mine, obviously I want to turn the armature, because I'm going to have my my cotton swab up against the commutator right there, and the armature is again the whole shaft, drive shaft section and motor as it turns. Now, what I'm going to do, once I get my cotton swabbed, wet, not dripping, but just wet with the alcohol, I'm going to put my cotton swab right here, and I really like these new ones I have that are from the cosmetic counter because they're flat. Makes my job a little easier here. Now, I'm going to hold it, and then I'm going to reach up, and let me scan out just a moment. Remember the worm gear? Okay, I'm going to grab a hold of that with my other hand, and I'm going to turn it because I need the commutator to turn. Get my zoom back here for all of you. Yeah, there we go. Okay, so I've got my cotton swab, got my alcohol. I'm just going to turn. Let me turn this way. And I'm just going to hold the cotton swab against the commutator. You don't have to smash it or anything. Just hold it firmly, and I'm turning. And as I turn that worm gear, it's turning the commutator. Now, by the way, if you press too hard on the commutator, it'll stop turning. So you don't need, again, you don't need to squash it. Just hold it there, and you can see the alcohol pulls this off. 99% alcohol is extremely important here, because, and I'll try this other. Oh wow! Look, you guys see that dust stripe is already lightening. Look at that. And I'm just going ahead and use the other end of the swab here, and and just place it against the commutator. You can see I don't have as much contact on it, but that's okay. Maybe I can try sticking it in this way. Yeah, get more coverage, get that, okay. And I'm just, like I say, turning the worm gear. And again, don't take the cotton swab, don't push it too far in, because the last thing you want to do is get any shedding of the cotton fibers. This has not. I think these are a bit higher quality than your run-of-the-mill generic store brand cotton swabs. Okay, so I've just got a clean cotton swab, and I've dipped it in alcohol. I'm going to keep going. Make sure I've got my angle there for you all so you can see. And I'm still getting some. You may ask yourself, well, how do you know when to stop? The more I clean, the lighter the cotton swab will get. Am I going to keep going until the cotton swab is completely white in color? When I do this, not necessarily. We'll give it one more go here. Do it this way here. And you can see what came off on there. It's not, again, it's getting lighter. Now, take a look inside there. That is, get one more swab. I got this one here. In fact, even the grooves of this commutator, I don't even see basically no buildup in it. That is, to me, it's not just the fact that the brushes are almost brand new in length. It's, there's not even much buildup in these crevices. And yes, if you technically take this out and you take there's a metal tool that you can use to pull the carbon out of these little gaps that you see, these little places in the commutator. But I'm not going to do that. I just gave it six passes. Whoops, with the, sorry about that. I gave it 6 passes, right? I had 3 cotton swabs. I used both ends in the 99%. And from my perspective, this is an incredibly clean commutator. If it had been dirtier to begin with, I might have needed to do a little bit more. But again, I stick by my 99% isopropyl alcohol. Some people have used electronics cleaner, but electronics cleaner is mostly alcohol. What you don't want to do is do not use 50% or 60% or whatever alcohol, because the rest of that is water, and we don't want to introduce water here. 99% isopropyl alcohol is, I got mine at Costco. It's not expensive, and it evaporates almost immediately. So I'll give it some time to dry there, but there's really not much else to say. Just an incredibly beautifully made motor, because even in the early 60s, as Singer was under significant pressure to lower costs and to, you're either going to take features away, which would be hard because the competition was offering an increasing number of features. So it's either that or you have to cut costs on material and construction. But thankfully, when this Touch and Sew was launched, 1962-63, model 600E, that's got a lovely motor. They had not gone to cheap, crappy motors. Again, would it be nice to have Would it be nice to have a grease port? Oh, yes. But I'll take this, believe me, compared to what goes into many modern consumer products today, nothing is made this way. Now, I have not looked at a modern sewing machine motor, not on the cheapies, because a lot of the consumer grade sewing machines they're really cheap and poorly made. If any of you have ever seen the inside of a modern day Bernina motor or a modern day top of the line Janome or any of the other modern sewing machine brands that have really expensive models, and some of them do. Is the motor this strong? Is it made this way? I don't know about the strength, but some of you might be able to answer that for us. And again, this is subjective. Is there a way to objectively measure the power of a sewing machine electric motor? There might be, but I don't know that anyone has. So anyway, I hope that this was helpful. I don't talk about these motors very often. I've shown them, but I am going to make the claim. I'm going to make the claim that this is arguably my favorite motor in all of vintage sewing machines, even more so than the potted version. I mean, it's just a servicer's dream. They're strong. You always need to open them. You need to check if you have any concerns. If it's not running right, can they be damaged? Yes, they can. Nothing is. There are no guarantees. But I have to say, goodness. Oh, I have yet to come across a sewing machine motor that is easier to access and that is as durable as this one is. Thank you all for watching. Feel free to donate to the channel to help my efforts, support me in trying to find more of these machines to rescue and save. They still, to this day, I hear this from people who sometimes go up, they have to go to a local landfill or a dump to drop things off. And they sometimes tell me, oh yeah, they still see vintage sewing machines there, because many people, they don't know how to assess if it's worth anything, or maybe it's not running and they assume it's broken because they're used to modern consumer products. And many modern consumer products, when they break, they're disposable. They're the textbook example of planned obsolescence. But our ancestors' consumer products were not like that. And I'd like to think that we honor past generations by trying to save the items that they built with quality, that they had to pay a lot for, and it was not, they weren't all rich people just, saying, hey, I'll take a couple. It wasn't like that, but they were willing to pay because they trusted in a brand, they trusted in the quality, and they knew that if there was a problem, it likely could be repaired. And that's not something that we currently have right now. But anyway, if you have a favorite vintage sewing machine motor, if it's this one or another motor, just put your comments down below. We'll see you next time.